Hi students, welcome to physics class. Today we are going to discuss about projectile motion. Now hi students, once again I am repeating. Today our concept is projectile motion. Tell me, what is projectile motion? An object that is in flight after being thrown or projected is called projectile motion. I am writing here, listen carefully. An object that is in flight after being thrown or projected is called a projectile. Once again, an object that is in flight after being thrown or projected is called a projectile. The motion of a projectile may be thrown the motion of a projectile may be throw off as the result of two separate simultaneously occurring components of motion. Once again I am repeating this point, my students. The motion of a projectile may be thrown off as the result of two separate simultaneously occurring components of motion. Now point number 3. One component is along a horizontal direction, is along a horizontal direction without any acceleration, without any acceleration. Without any acceleration, and the other along the vertical direction. Along the vertical direction. Along the vertical direction with a constant acceleration. With constant acceleration. With constant acceleration due to the force of gravity. Due to the force of gravity. Please stop. My students, now I would like to tell some important points. Please remember. Now take x-axis, take y-axis. If a body which is projected with a velocity u, this is makes an angle theta with x-axis. This u makes an angle theta with x-axis. Here 2 points we have to remember. This x-axis we called as ux component. That ux is equal always u cos theta. Similarly, this is we called as uy component. That uy component always called as u sin theta. Similarly, ux component always called as u cos theta. This is fixed. Once again, remember, take a body projected with a velocity u, which is makes an angle theta with x-axis. This is ux. Similarly, the y component we can call as uy. That ux we call as u cos theta, and that uy we call as u sin theta. This is fixed point. We have to remember this is very important. Now consider a body is projected with a velocity u. This is theta. This is O, origin. Consider this is x. Here, this is ux. This along x direction we call as ux. This point we call as B. This is uy. Earlier what we discussed, that is ux is equal u cos theta, uy is equal u sin theta. Once again, I am repeating, take a body which is projected with a velocity u. Now it is projected and hit the body at a point B of the ground on x-axis. Now the x-axis we have to take as ux and y-axis we are taking as uy as velocity components. That ux is equal to u cos theta, uy is equal to u sin theta. Now draw a perpendicular to y-axis and draw another perpendicular to x-axis. Obviously, this is y, this is x. Consider at the center point, this is we called as h, called maximum height. Maximum height. Here, take this one is u cos theta. Why? This is parallel to this line, parallel to x-axis. If it is parallel to x-axis, this is u cos theta. Now consider this vertical line is u sin theta. Vertical line is u sin theta. Here one of the component is along the horizontal direction without any acceleration, and the other along the vertical direction with constant acceleration due to the force of gravity. That means here u sin theta, u sin theta, u sin theta, here u sin theta is equal to 0. Once again u sin theta, u sin theta, u sin theta. Whereas in case of u cos theta, which is constant throughout the motion. This is about projectile motion. Now our concept is projectile given. Projectile given. Projectile given angular projection. Angular projection. Once again, projectile given angular projection, or the another name is the path of projectile. The path of projectile is parabola. Parabola. Once again, I am repeating. The path of projectile is parabola. Now, what is the question? The examiner asked, projectile gives angular projection or the path of projectile is parabola. Now, this is the question. Now, go for discussion. Take x-axis, take y-axis. A body is projected with a velocity u, which makes an angle theta with horizontal. Therefore, this is ux, and along y-axis the velocity is uy. This is O. Therefore, ux is equal to u cos theta and uy is equal to u sin theta. Now take a body which is projected with a velocity u, which makes an angle theta with x-axis. Therefore, along x-axis, that is ux, along y-axis we call as uy. Here ux is equal u cos theta. Similarly, uy is equal u sin theta. Consider this is O. This is where the body hit the ground, called B. From that means O to B we called as range. Suppose the body reached to maximum height here. Consider here the point is, this is A, this is H. AH is called maximum height. Maximum height. Now O to B through projectile we called as time of flight. Here O to B horizontal we can call as range. O to B horizontal we can call as range. Now O to B on the projectile gives time of flight. This is u cos theta. Here u sin theta is 0. Here u sin theta is 0. Here u sin theta is 0. Here u sin theta is vertically downward direction, but u cos theta is horizontal direction. Consider this point. Take one horizontal, take one vertical. This is ux, this is uy. Here ux is equal to u cos theta, uy is equal to u sin theta, not equal to 0. This is the velocity direction. In case of here h, u cos theta, ux is equal to u cos theta, not equal to 0. Whereas at h, uy is equal to 0. Therefore, u sin theta is equal to 0. Yet h ux is equal u cos theta not equal to 0, whereas uy is equal u sin theta is equal to 0. This is very important point. At h ux is equal to u cos theta not equal to 0. At h uy is equal to u sin theta is equal to 0. That means at maximum height, at maximum height, at maximum height. Okay, this point is important. Now go for the discussion. Suppose an object P projected with velocity u, making an angle theta, with the horizontal direction, with the horizontal direction. Once again, I am repeating this point. Suppose an object be projected with velocity u, making an angle theta with the horizontal direction. Resolve velocity u into two rectangular components. Along OX direction, that is horizontal direction. Is u cos theta. Once again, I am repeating. Resolve velocity u into two rectangular components along OX direction. that is horizontal direction is u cos theta. Next, along OY direction, OY direction, along OY direction, that is vertical, direction is u sin theta. Once again, along OY direction, vertical direction is u sin theta. Okay, now the horizontal the horizontal component velocity, u cos theta is constant, throughout the motion. Throughout the motion. Once again, the horizontal component velocity u cos theta is constant throughout the motion. Next, the vertical component velocity, u sin theta is decreases with height, from O to H due to gravity. My dear students, once again I am repeating the point. The horizontal component velocity u cos theta is constant throughout the motion. The vertical component velocity u sin theta is decreases with height from O to H, due to gravity. At point H, at point H, the object has only horizontal component velocity. only horizontal component velocity, that is u cos theta. Once again I am repeating this point. At point H, the object has only horizontal component velocity, that is u cos theta. The vertical component velocity, u sin theta, is increases from H to ground point B. Once again, B. H is maximum height. H is maximum height. H is maximum height. OB is horizontal range. My dear students, once again I am repeating these points. The vertical component velocity u sin theta is increases from H to ground point B. H is maximum height. OB is horizontal range. OB is horizontal range. Now go for the derivation. Now motion along horizontal direction. Now we are going to discuss about two directions. One is motion along horizontal direction OX and motion along vertical direction OY. At first we are going to discuss about motion along horizontal direction. The velocity of an object in the horizontal u cos theta is constant. The acceleration ax in the horizontal the horizontal is 0. Once again, I am repeating this point. The velocity of an object in the horizontal u cos theta is constant. The acceleration ax in the horizontal is 0. The position of the position of the object at any time small t along the horizontal direction. Along the horizontal direction is given by once again, the position of the object at any time t along the horizontal direction is given by, that is s is equal ut plus half a t square. Here s is equal x and ux is equal u cos theta, and acceleration along horizontal always 0. Therefore, x is equal to u x small t plus 1 by 2 a x t square. That is, x is equal to what is u? Ux is equal to u cos theta into t plus 1 by 2 into ax is equal to 0 into t square. Therefore, x is equal to u cos theta into small t. Therefore, small t is equal to x whole by u cos theta. Consider this is equation number 1. Once again I am repeating, x is equal to uxt plus 1 by 2 ax t square. X is equal to u cos theta into t plus 1 by 2 into ax means 0. 0 into t square. Therefore, x is equal to u cos theta into t plus 0. Therefore, t is equal to x by u cos theta, equation number 1. Now, we are going to discuss about motion along vertical direction, that is OY direction. Since the vertical velocity since the vertical velocity of object is decreases from O to H due to gravity. Due to gravity. Once again, since the vertical velocity of object is decreases from O to H due to gravity, the acceleration AY in the vertical direction is not zero, that is AY is equal minus G. Once again I am repeating this point. The acceleration AY in the vertical direction is not zero, that is AY is equal minus T. Next, the position of the object at any time t along the vertical direction is given by once again, the position of the object at any time t along the vertical direction is given by the position of the object at any time small t along the vertical direction is given by, that is S is equal ut plus 1 by 2 a t square. Here S is equal y and u y is equal u sine theta and ay is equal a sine theta. Therefore, S means y. Y is equal to u y t plus 1 by 2 a y t square. Now y is equal to, what is uy? U sin theta into small t plus 1 by 2, what is ay? A sin theta into t square. Consider this is equation number 2. Consider this is equation number 2. Once again, y is equal to, this is y direction. Therefore, uy t plus 1 by 2 m is along y direction. Therefore, ay t square, that is equal to, y is equal to, what is uy? U sin theta t, as usually t, plus 1 by 2, what is ay? A sin theta into t square. Consider this is equation number 2. Therefore, equation 1 in 2. Once again, equation number 1 in 2. Y is equal to u sin theta into x whole by u cos theta minus 1 by 2 into g into x by u cos theta whole square. Once again, y is equal to u sin theta into x by u cos theta minus 1 by 2 into g into x by u cos theta whole square. Therefore, y is equal to x into sin theta by cos theta, tan theta, u going to be cancelled, minus g by 2 u square cos square theta into x square. Let a is equal to tan theta and b is equal to g by 2u square cos square theta. Therefore, the y becomes as a x minus, this is b x square. Consider this is equation number 3. Tell me what we get? We get y is equal to ax minus bx square. Consider this is equation number 3. This is an equation of a parabola. This is an equation. This is an equation of a parabola. Once again, this is an equation of parabola. Hence, the path of a projectile is a parabolic path. Parabolic path. Once again I am repeating this equation number 3 we called as this equation is an equation of parabola. Hence the path of a projectile is a parabola. Now today we discuss about what is a projectile motion and prove that the path of projectile is a parabola. I hope you understood this video. Thank you very much for watching this video. Thank you.